Did you ever notice that pi squared, which is 9.87, is kind of close to the value of Earth's gravity, g, which is 9.8? Kind of a fun coincidence, right? I mean, it has to be a coincidence, right? Surely. Because, they don't even have the same units. And why would they relate in any way in the first place? Other planets definitely don't have the same gravity as pi squared. So that's settled then. It's just some dumb luck and that's that. Or is it? Well, turns out that in this case, luck has no part in this coincidence. And actually, the story behind this curious relation is pretty nice. It all started with some French guy named Jean Piccard. Jean Piccard was this astronomer priest guy who, aside from astronomy, also dabbled in all sorts of other physics. Amongst other things, he had a neat idea that would revolutionize the way scientists cooperate by fixing one small annoying problem. You see, back then, scientists wanted to compare measurements with people that were either far in the past or physically far away. But these comparisons were very chaotic and impossible to achieve at times because of a pretty stupid and inherent difficulty. Let's say that you and your friend live at two different sides of the world. And let's say you both like growing carrots. Also, you specifically want to compare the sizes of your carrots. But how would you do this? You don't want to send your carrots halfway around the world, right? Instead, you both simply measure your carrots with a meter and pop over a text message with the measurement. Or in other words, you both have a unit stick that you use as a reference to gauge the length of your carrots. But here is where we reach the issue. How do you know that your unit sticks are the same? And even if they were the same, how do you deal with the fact that the local monarch comes over and decides to break your stick in two? Take this line of thought and now expand it to a network of friends comparing their carrots around the world. Each not exactly sure how to convert their unit stick in terms of the other's unit sticks. And you truly get into a real mess. Wouldn't it be cool if we could bypass all that? For example, what if everyone had the same exact unit stick right above their head all day, every day? Well, turns out that we sort of all have that. Just not for measuring length, but for measuring time. A full day is exactly the same everywhere. 24 hours on the dot. So we don't need to physically transfer an hourglass in order to compare times. You just need to look at the sun and calibrate your instruments using that. Great, right? If only we could have used that for measuring our carrots. Well, this is where our friend Jean from earlier comes in. So in 1671, this guy realized that around 70 years ago, Galileo found that the time it takes for a pendulum to oscillate depends only on its length. And so, he thought that if everyone constructed a pendulum that takes exactly 1 second to go from one side to the other, then all the pendulums would have the same length. And thus, this would be a way of converting the universal time units that we all love into universal length units. Swell idea, right? 4 years later, some other guy calls this unit of length metro católico, which means universal length, and it started to catch on. But then it hit a snap. Turns out that the lengths were different, around 0.3% different. If you're wondering, we now know that these differences result from Earth's rotation. Anyway, so this metro unit isn't really universal, so they still had to send unit sticks around. But at least it's reproducible, so why not keep it around? And so, it was still in use, and eventually, when the French moved to define the meter, a more universal unit length based on Earth's circumference, they made sure to divide the circumference by 40,000, so that it ends up quite close to the then popular Metro Coatlicue that Jean Piccard invented. Okay, cool story, but what does this have to do with pi and g, right? Well then, with no further ado, let's get right into it. Let's take Jean's pendulum. The time it takes such a pendulum to go from one side to the other is exactly 1 second. But also we know that it has this expression. Let's use Jean's metro thingy as our unit length. So that means the length is 1. And so now if we rearrange this thing, we get that g equals pi squared. Meaning that in the length unit that Jean Piccard invented, g was actually exactly equal to pi squared. And the fact that this is still almost true to this day is a remnant of the fact that the meter was originally defined using the seconds pendulum,